Okay, I had to look around because I couldn't find it in my email, the kit. I believe this is the same kit that I just put together. I ordered it a long time ago, actually. And it's the same chip, the ICL8038 function generator. It looks like it's all the same components, and it looks like it's exactly the same board. That's about what I paid for it. And I will put the link, I guess, in the description. And let's put this thing together. Okay, and I got this one also in the mail, and hopefully this is the frequency generators that I ordered, kit. And I'm going to try to combine these cheap frequency generators with the cheap frequency counters. Yeah, I think these are the frequency generators. And well, let's just build one first, and then if I put them both together, I could have a cheap little frequency source with I'll tell you what the frequency generator, basically number display output. And like I said before in one of my other videos, one is none, so I got two just in case, because I got one that was missing some parts, and it got fried. The directions were so vague that I couldn't, it was so bad. I haven't posted the video because I usually like to post success stories, but maybe if people are interested, I'll post the Tesla coil video that failed. Sometimes my projects do fail too. Anyway, let's try to assemble these things and see what happens. Okay, so I guess maybe let's just open up this kit here and see what we got. Oh, here's a circuit board here. And directions. Should I be scared? It looks like they're in Chinese, maybe. Oh gosh, completely in Chinese. Look at that. Although it does have a wiring diagram. Oh my freaking god. Nope. At least I understand the kilohertz. Okay. So let's see what else we got here. A whole bunch of capacitors. Here's some. Well, at least they have this. I like it. These sockets are nice because then you don't have to worry about burning out the IC. Not that I've ever burned out an IC when you're soldering it, but if you want to replace the IC, you can just unplug it. So that's nice. And looks like a power plug. There's no power supply, of course, with it. Here's our dip pin. And it looks like some of the legs are bent. You want to be very careful when you bend them back so they don't break. The legs break. That's like the kiss of death right there. You do not want the legs to break. Let's see. I'll look under the magnifying glass and see what this is. Looks like ICL8038CCPD. Okay, so that's what that chip is. Whatever that is, I'll have to look it up. We got some headers here, some potentiometers, little potentiometers. Like I said, I ordered two of them just in case. Here's a tiny electrolytic. I don't think I've ever seen an electrolytic that small, but maybe. And a bunch of capacitors, and I'm not sure if I'm going to be able to. Yeah, the last board, it was like a freaking puzzle, trying to figure out what values of capacitors go where, because, I mean, his constructions were horrible. Okay, so we'll see if we can get this circuit to work, because I'm starting to get a little bit worried about this whole thing. It does have different values of resistors and this is, oh wait, maybe there's something understandable here in English. Okay, look at that. In this column over here, it's got stuff that I might be able to understand. Oh, look, here's some 1K, 20K. Okay, so let me try to populate this board up, and we'll see if we can get this little frequency generator thing to work. Okay. Looks like it was made in 2019 in China, of course, because everything's made in China. Because our leaders shipped all of our jobs over to China, right? Because what is it, the World Trade Organization and all these other organizations that want to destroy our sovereignty have been like termites whittling away at the integrity of our country for a long time. And then every time you get pissed at them, oh, what we're doing, we're all innocent. What we're doing is not that bad. Well, when the food shortage comes and people start dying, it's like a house that's got termites in it, right? When you let the termites just keep on chewing on the house and chewing on the house, each little bite doesn't count that much, but when the house falls down and kills everybody, that last little bite is like the straw that broke the camel's back, right? That last little bite counted a lot more, and you should have been killing the communists way before then. But anyway, I'll keep the political stuff out of this video and see if we can get this silly circuit to work. Alright. Okay, so I like to start out with the easy stuff first, and it looks like there's 5 resistors here, and I noticed on the directions, these wonderful directions here, that resistor 1, 3, 5, 6, and 7 are all 1K. There should be 5 of them. I suspect it's these 5. And so let's just test it, I guess. Okay. And 1K is a very popular type of resistor. And it looks like this is 1K, so all these should be 1K because they're on the same batch. And so let's just try putting these in. And again, it's 1, 3, 5, 6, and 7. So I can see there's resistor 1 is right there. So let's populate that one. Let's take that guy off and like to bend the leads down like so. Okay. My eyes aren't as good as they used to be, but I can still see, so that's good. There's resistor 1, and it looks like the distance between the two holes is a little bit shorter than it should be. But what you're going to do, okay, let me look for the other resistors now, populate them up. Okay, I think I found all the positions of the resistors for the 1K. There's one down here, one there, one there, one there, and one there. There's all 5 of them. And let me try to go on to the next, maybe R2, and see if we can put that one in place. And we'll solder all the resistors up. Okay. Okay, so it looks like this resistor here is 20K. And that's what they say R2 should be, so I'll try to find that on the circuit and put that one in place. Okay. Okay, so it looks like R2 is over here on this side of the circuit, right above the jumper, well, I don't know what you call that, where you can put the jumpers in to change the frequency. So here's where R2, the 20K resistor, goes. And we'll, oops, the leads are starting to bend. Sometimes I like to try to pull them through in the back if they start to bend when you force them in the front. I bend them outward. So you pull it through in the back, like so. And then I bend them outward so they don't fall out until I solder them. So there's where R2 goes, right above this pad right there. Okay. Okay, so here's our last regular resistor, and just make sure it's supposed to be about 82K, and it looks like it's measuring out about 80K. Okay, so let's put that one in the last spot. Okay. Okay, so it looks like R4 is right beside this, excuse me, this 10 pad jumper area. And so let's get the resistor ready. We'll bend the leads down like so. and we'll stick him into this position right over here. Gosh, go in there, come on. Like I said, I'll sometimes pull the leads through on the back if they're not coming when I push them. Okay, and spread them out so they don't fall back through. So there we go, there's the last resistor R4 that I put in. And I think we're ready to go on to, I don't know if I'll solder these next or populate some other things. Let me take a look. Maybe I'll look at the capacitors and put them in. And I'll solder them all up. Okay. Okay, I can't really call these directions. I'll call them a cheat sheet, I guess, because they are definitely far from directions. But I'm looking all over and I'm not really seeing, this big capacitor here, the electrolytic one, is supposed to be C1, and I don't see it on the chart anyplace. There's an IC1, but no C1. And you can kind of maybe trace the circuit on the back and maybe figure out what some of the components are. I'm going to guess, though, since there is a, where is it? There is a big electrolytic capacitor and a smaller electrolytic capacitor, and there is two electrolytic capacitors on this circuit here. One's bigger and one's smaller. I'm going to assume the bigger goes with the bigger and the smaller goes with the smaller. And of course, remember, electrolytics are have a polarity. You don't want to plug them in backwards. Looks like there's a plus right there and a plus on that side. And so let me try to plug these guys in. Well, I'll just do it right now. What the heck? So there's the stripe for the negative side, and so the negative side is going to go toward the white. All right, put the bigger one over there. Okay, and of course spread out those leads on the bottom so it doesn't come out. And we'll put the smaller one in here. Again, the longer lead's the positive one, and there's the stripe on the negative side. So we'll put the positive lead toward the positive in the circle there. Okay, and spread out the leads so they don't fall out, and always try to solder it. And so I think this board is starting to come together. Let me look at the other ones. A lot of the other capacitors are not labeled. That could be fun, trying to figure out what that is. Well, I think this is a transistor up here. Very few components have 3 leads. And of course, here is our transistor. It's a little 3-leaded transistor. I'm going to assume that the flat side of the transistor goes to the flat side here. Let's just stick that guy in. Get those 3 things into the 3 holes there. Come on. Oh, come on. Where are those holes? Yeah, of course they're not. Let me just put it here at a different angle so I can see it. Why is it so hard? I think the holes are spaced out about twice as far as the lead spacings here, so this transistor is not going in there very well. Plus it's hard for me to see this anyway. Maybe I'll stick it under the magnifying glass and get it in there. Okay. So it looks like I got it in there, and there's the 3 leads going through, and of course it's spreading them out because the holes are much farther apart than the lead spacing on the transistor. And so that's where that transistor goes. Little capacitor, big capacitor. And we'll see if we can get some other components populated in there. Okay. Okay, so I guess we got all the parts on there, and looks like our soldering iron is up to temperature. You can tell because it's smoking. So let's just go ahead and solder this together. Oh, see this. That's why you gotta bend the leads. Okay, I'll put that one on later. Of course, when you're soldering, you want to touch it to the wire and the pad, and then just heat the whole thing up and create a good solder joint so it wicks onto both. Probably can't see that with this camera. No. All my stuff's falling off. Anyway, I'm just going to go ahead and solder this, and we'll test it out and see how the thing works, okay? Okay, like I said, building this circuit is kind of like a puzzle. I don't know if you can see these there. This is through the magnifying glass, but these are 104, and there's 4 of them. And our little cheat sheet here says that capacitors C9, C7, C4, and C3 should be 104. There should be 4 of them. So I've identified 4 capacitors that are identical and have the same markings that we're looking for. And so I'll try to find the places on the circuit for this guy. Okay. Okay, what did we say they were again? 9, 7, 4, and 3. Okay, so C3 is right here. That's one of the tuning capacitors. So we can stick him in there. Okay. Of course, since these are the tuning capacitors, they're all going to be different. Okay. 9, 7, and 4 still. Okay, looks like C4 is up here. So we can stick... Oh, that's C7, I'm sorry. C7 is right there. Okay. So we have 3 and 7 in there. And so we need 4 and 9 still. Okay, looks like C4 is right next to C7, right here. Okay. And 9's right over here, under where my finger was. Okay. Okay, so there's the 4 positions of these identical 104 capacitors. 1, 2, 3, 4. I'm going to bend the leads outward again so that they don't fall out while I'm trying to work with the circuit or solder it or whatever. Okay, I'm starting to get a lot of leads on the bottom. But that's okay. Just being efficient, right? I can bang this circuit out quickly then, maybe. Okay. And we'll see if we can figure out where those other capacitors go. Okay. Okay, I'm sorry, I guess there was another column over here. C1 is over here, the electrolytic that we put in before, and I guessed that the big one goes with the big one, but yeah, you can see that the big one is 47 microfarads, just as they say in our little cheat sheet here. It should be 47. Okay, so we'll continue on, try to find where the other capacitors go. Okay, okay, so C2 is the top tuning capacitor here. If we look over on our cheat sheet here, it says C2 is 105, value of 105. And I don't know if you can see that, but it's this yellow wide one. It does say 105 on it. And the leads are kind of wide to fit into this hole. I'm going to have to probably bend them in a little bit to fit into this top position up here, or the C2 position. Oh, come on. Again, this is how it's tuning through the different ranges of frequencies. They have different size capacitors, and you just put a jumper, it looks like, on this jumper header thing, and I'm going to push this capacitor over so it's not interfering when I try to stick that jumper header thing on there. Okay. There's C2. Okay, so here we have C5, says it's 103. Okay. And this capacitor here is labeled as a 103, and C5 is the next tuning one below C3 on this little header thing over here. So we'll put in capacitor C5. Okay. See how the capacitors are getting smaller down here? Okay, let me bend those leads out. Okay, so there's C5. Okay. Okay, and again, here we'll look here. Oh, C6 is over here, and it says it's 102. Yeah, it's getting hard for me to even read through the magnifying glass, but that looks like a 102. So these things are going down by decades, or by multiples of 10. So we'll put the C6, which is the next one down, the tuning capacitors, right there. Okay. And we'll bend those leads out. And then the last one in that line is C8. Okay. Okay. So C8 says it's a 331. Okay. And I believe that says 331 on it. That's really hard for me to read. And that is the last capacitor in our kit, so it's got to be the right one. I'll put that into the C8 position. And there we go, they're all fully populated, the tuning capacitors right along here. Okay. Bend those leads out. Come on. Okay, let me take a look and see what needs to be done next. There's our circuit so far. Okay, and I believe there's only one diode in this circuit, and it is a light emitting diode. And they're giving us a little clue as to, I think usually the positive lead is longer, but it has a flat side here. Of course the positive would be on this side because the negative's on the side where the line is. But, so there's a clue. Oh. But they're also giving us another clue that this has a flat side on one side. See, there's a flat side on this diode thing up here. If you look very closely from the top, there's a flat side here on the light emitting diode, and it happens to be on the short lead side, exactly how you'd expect this to go into here. So let's just, of course these leads are thicker, so they're barely fitting in the holes now. So see that? The flat side here is consistent with the flat side there. So I think that's probably in the right way, because remember, you don't want to stick diodes in backwards. Either the circuit won't work or you're going to blow something. So hopefully that's right. You got to get everything right. Remember, you always double check before you put power on it, because that will destroy it. In fact, you should double check before you solder it. Okay, so maybe I'll start putting these potentiometers on here, and you want to look on here to see that on this little dial on the top, they have different numbers. One of these says, I think it's 103, one says 104, this says 203 here, and there's a couple other ones, there's a total of 5 of them. And so I'm going to see if I can figure out, using these amazing directions, exactly where these things go. Let's see, I guess they're called RP. So if we look up at RP1, that should be 10K, RP2 is 1K, 3 and 5 are 20K, and RP4 is 100K. So maybe we can figure out where those go and stick them into the circuit. Okay, so I believe this resistor labeled 203 is probably the 20K, and you want to be careful. You want to measure it from these two leads here, the two leads on this end. Okay, and you don't want to touch it with your fingers because the resistance of your body will interfere with the reading of that. It looks like it's about 18K, so that's, I guess, close enough. Okay, so we'll try to plug these two, the 203 ones in the positions that they're supposed to go in. Okay, so our directions here say RP3 and RP5 are 20K, and so if we look at our circuit, RP3 is up here and RP5 is down there. So let's just plug these guys in. Of course, there's 3 leads here. Okay, there's that one. And they're kind of bent so they stay in place fairly easily. There's RP5. Okay, those are both labeled 203. Okay, I'll see if I can find where the other ones go. I think we're getting close to being done with this guy. Okay, so our cheat sheet says RP1 is 10K, and I measured this one out to be about 10K, and it's labeled as 103. Not exactly what I would have expected, but I guess 103 must be the 10K one, and RP1 goes into this position up here. There we go. Okay, so we just have 2 more to go, RP2 and RP4. Okay, this is labeled as 102, And our directions say that that should go into RP2. It says 1K. This is a 1K resistor. Okay. And the last one is supposed to be 100K, and it's labeled 104, but I measured mine to be about 88K, but it's got to be the one that goes there because it's the only one that's left. So there we go. Our circuit's looking pretty populated now. And what else we got? We got a few more things to stick in there. Imagine the IC socket thing goes here, and there's a notch on one end, and see there's a notch on that end, because these things are polarized. They go in a certain direction too. See? Please tell me these are going to fit in those holes. Oh, come on. I'm going to have to fiddle with that, but that's where that's going to go. I don't know if those blades are going to fit in those holes that they drilled or not, but that would be par for the course for these cheap circuits, right? Let me fiddle with it and see if I can get it in there. Okay. Of course, you want to make sure before you stick it in that all these are straightened out, because you don't want to bend one of those over. Make sure it's in the right direction. I kind of twirl it back and forth. Okay, there, it went in the hole. Okay, so our IC socket is now in place and it's in the right orientation. And let's see, what? Oh, we're gonna have to cut this header. It looks like part of the header goes here and part of it goes over there. I'm gonna have to figure out a way to cut that. It's like 5 pins over there and 3 over there. They give me a total of 8. I'm gonna have to get maybe a pair of dikes or something and chop that up. Okay, so more fun. Well, you know what? I just have a razor blade here, and maybe I can get it kind of scored with the razor blade. Maybe I can just cut through it. 3 and 5, right? Let's put this down here. Let's take a look down here. I'll try to be careful not to cut myself, because that sucks when you cut yourself with a razor blade. Okay, you don't want to break the razor blade and have it go in your eye or something. I'm going to probably stick the camera down while I do this operation, because I don't want to get hurt doing this. Okay. Okay, well, I found a pair of dikes. Hopefully this doesn't mangle it. Oh, shit. Come on. Let's see, I started to score it already. Maybe here. Okay, whatever. Hopefully this doesn't destroy it. Shit! I don't know where that went. Okay, word to the wise. Keep a hold of both halves when you're cutting something with dikes, because they'll go flying. I got the 5 side here. I'll try to find the 3 side, or maybe I got some other headers someplace else I can make do with. Okay. Okay, you ever hear the expression robbing Peter to pay Paul? I did get a second kit, so I keep this project going. I stick this thing in the bag while I cut it this time. So both pieces are in there, and I'll try to find probably another header, because I don't think I'm ever going to find that one that shot off over into that pile of junk over there. So let's borrow this one for now, and then when I build the second circuit, we'll see if we can maybe get some more header material from Micro Center or something, because I might have some of my robot stuff. We'll have to see. Okay. So it looks like part of the header goes over here. Okay, like so. Yep. And then the original 5 one that I have goes here. Like so. And, well, I guess there's another single line header. It goes over here. Looks like I'm going to need 3 jumpers, and hopefully I have 3 jumpers in that kit, but again, I ordered a second kit. So, yeah, I'm only seeing 2 jumpers in the first kit. So, whatever. And here's our power plug, and I think we're all set, and we're just going to have to start soldering this thing up. So that's what our fully built up circuit's going to look like before we solder it. And we have a couple jumpers here still, and I'm going to leave the IC out while we solder it, because that's the whole point of having a socket plug, is so you can solder without the IC. We'll solder this thing up and then maybe test it out. Okay. Should be interesting. Okay, I can tell you, if you do a lot of soldering, it's handy to have one of these magnifying glasses here. And you should examine the solder joints. I only did the long leads, and I'm going to try to wish I could find a better pair of dikes, but one way to clip these leads is to use a pair of dikes and just get down right close to the root of it and clip her off like so. Okay. And because you don't want them to short against each other, that would be very bad. And so I'm going to go trim the grass here. Oh, come on. This pair of dikes is not the greatest. It'd be nice to have a smaller one. Looks like it's magnetic too, or maybe it's the Vaseline that was stuck on there from the last experiment. Okay, let me trim these down, and then it'll be easier for me to solder the short leads on there, and we can finish up the circuit. Okay. Okay, that looks better. I trimmed them all down, and now I can get the ones on the short pins, solder them down. And you want to also inspect it to make sure there's no solder bridges between things that shouldn't be bridged. You don't want to short things out. The circuit's not going to work right. It's going to probably burn stuff out, maybe. Okay, let me finish soldering this up, and then we'll be able to test it out. Okay, so I've been looking the circuit over, and I think it might be good. There's a solder bridge there, but those are connected to the same pad anyway, so I think that's fine. I'm not going to worry about getting rid of that solder bridge. And, oh yeah, well, where's our IC? We need to plug that in. Where did our stuff go? Oh, okay. Well, we're almost done. Okay. Okay, so here's our IC. And you want to make sure it's oriented proper. You want to make sure all the pins are straight. You don't want to bend the pins as you're sticking it in. You want to be very careful about that. So the IC typically has a little, I don't know if you can see that, there's a little divot on this side over here. And that divot's going to go pointing toward the same way as this little notch on the, what do you call that thing? Okay, I need to bend all the pins in a little bit. They're typically sticking out a little bit more than they need to be to fit into the socket. Okay, we'll call it a socket, yeah. And you want to make sure that all those pins go right down into the right holes and none of the pins get bent, because that would be bad. Okay. Like I said, usually I'll squish it in a little bit like this. Make sure they're all even, so they can go right in the slots down there. Do not bend any of the pins over. Make sure they all go in straight. Watch it very carefully, and there we go. Okay, so there our IC is in place. And there's some jumpers, and I think I understand what this jumper is for, at least. This jumper selects different frequency ranges by, maybe you could put a rotary switch in there, because that's not really too convenient to have jumpers. And I'm not sure what this is. This is R3, J3, and something else. But there's another spot for jumpers over here. I'm just going to put the jumper on that right now. And so I don't lose the jumper. And I believe this is the output over here, the single header thingy over here, because the bottom one says ground, so there's two other ones that are in Chinese, and I'm not sure how I'm going to translate that. So I need to figure out what the output is, and I need to make sure, usually the center is positive, and it's probably 12 volts. Might need to look up the IC and see what the heck this IC is, and trace the circuit a little bit and make sure that I'm going to put the right voltage polarity on there, because I don't want to. One sure way to ruin your circuit is to put the wrong voltage polarity or the wrong voltage level. So we need to do a little bit of research, and then maybe we'll test this thing out. Should be interesting, huh? Okay. Okay, here's the data sheet for the IC8038, and if we read about it, it says it is a monolithic waveform generator, and it can generate a sine wave, a square wave, a triangle, a sawtooth, pulse waveform. Okay, so now I'm going to guess I know what that other jumper is for. This is probably what kind of waveform it generates, although I can't read Chinese. We can just try those different ones, but if it's up to me, I just set it on square wave and leave it, because I mean, balls to the wall, you know. The square wave puts out the most power. Sine wave and triangle wave are wimpy compared to square wave. And so when I put it into my amplifiers or anything else, if I want to, you know, I want to push things to the limit, typically I will want square wave. Okay, so here we go. 3 different waveforms: square wave, sine wave, and triangle wave. And there's the internal circuit of this guy. Okay, and I guess it can do some fancy stuff, which I don't care about, because all I want is square waves. Okay. And so anyway, there's the data sheet for our little chip here, the ICL8038. Okay. Very interesting. Okay, let's check out the voltage. Looks like anything up to 36 volts. Well, I don't think I'm going to push it that hard. It probably can't supply that much current anyway. At 36 volts, you probably wreck it. Yeah, it's only milliamps, but you can hook it up to a high power amplifier, which I think I've talked about in some of my very old videos, which I might do with this one, because we're going to be doing some interesting projects with this, I guarantee. Okay. Okay, after much fiddling around with this thing, I think I finally got a signal out of it. Okay. And oh, I couldn't get it to work at first. I have this variable power supply that I got from China, of course, and I set it about 6 volts. Maybe I can bring it down to, oh, see, if I bring it down to 5 volts, the thing doesn't work. Maybe that's why. If I have it above 6 volts, here we're going up to 7, 8. Okay, so 5 volts doesn't make this thing work. Okay, that's 14 volts. I think the manual said we could go up to well, about 36 volts. Okay, so I guess that seems to be, I can get these both in frame. Okay, so there we go. And let's try fiddling around with this a little bit. So I found that here, when I twiddle with this guy, this resistor here, potentiometer, that seems to change the frequency. Well, that's becoming very unstable. I wish I had a better okay, so there is, let's zoom this in, 136 kilohertz, and I'm on the second jumper down here. That looks like it's a square wave. I'm on the top jumper over here. I think these things determine the waveform setting. And when I start twiddling with, for instance, this potentiometer, this one in the top corner, or top right, seems to change the duty somewhat. And then there's this potentiometer right under the LED, and it seems to change the, well, I have it on AC coupling. Let's change it to DC. I'm not sure exactly. Okay, so this one over here seems to change the amplitude, I guess. Let's bring this guy down. So it's 0 to whatever, and then changing this potentiometer on the left-hand side over here under the LED seems to change. Well, I guess it'll go up and hit the rail if you bring it all the way the other way, so you must change how it's biased into the op amp. And here's a potentiometer here at the bottom. That seems to kind of change the amplitude without having to hit the rail. Okay. And I hit this one, and it looked like the whole thing died. I don't know what happened. I'm going to unplug it and see if I can save this thing. Okay, so I got it back. I re-brought the power back up, and I'm twiddling with this last potentiometer, and who even knows what it does, because maybe there's a bad solder joint someplace because it's not doing anything. Okay, let me try some of the different jumpers over on the waveform side and see what happens there. Okay. Okay, so now I put it on the middle jumper down here. Can you see that? And it looks like we have a triangle wave now. Okay. And maybe if I twiddle with some of these, it will change the shape or something of this triangle wave. Okay, there, I can change the shape of the triangle wave. It seems to change the frequency also. You can also change the frequency independently with this one right here. So this one changes the frequency, this one kind of changes the shape of it, the sawtoothedness of it. Okay. This one down here at the bottom still doesn't seem to do anything. This one over here, the bottom right, seems to change the amplitude. Okay. Let's try a different jumper setting. Okay, so now I put it on the bottom setting. This jumper on this side over here. It's on the bottom setting. And I guess that's a sine wave. And change the amplitude of it, kind of. Let's change the, I don't know what that one's doing. That one's not doing too much. Change this, shift it left or right, the shape of it. And of course, here's the frequency. Let me just try the different frequency settings. I want to put it back on square wave because I really prefer square wave. Okay. Okay, so I have it on the top, or I guess the bottom jumper setting on the frequency side over here, where all the capacitors are. And it looks like we're at about 306 kilohertz. Let me change the frequency. The frequency is this one over here. Okay. Looks like we're going up to almost 500 kilohertz there. And bring it down in frequency. Okay, so it's 33 kilohertz. And I'll bring it down some more in frequency. Or is that it? I guess that's it for this range. So the top range is about 33 kilohertz to 500 kilohertz. And turn the power off, we'll try a different frequency. Okay, so I have the jumper now set second from the bottom here. See it right there. And it looks like we're at about 200 kilohertz. And let me bring it down. to 39 kilohertz. Maybe it goes lower, I don't know. Okay, there. I guess we can bring these, twist them a little bit harder, and they will go, well, maybe it stops oscillating it if you twist it too far. Okay. I don't know. Okay, it's still oscillating at 3 kilohertz on this setting. Okay. So let me try a different jumper setting. Oh, okay, so this is the middle jumper setting, and it looks like if you go to the end of the range on these, sometimes this thing will stop oscillating. So middle one is about 21 kilohertz, and I'll bring it down here, twist this guy. Oh, come on. Wish I had a better screwdriver. Okay. You bring it down to where it stops. Okay. 600 hertz might go lower, but it might stop oscillating. I really like to leave it in a not-oscillating setting because I'm feeling like that might be burning something up or running the chip in a region it's not supposed to be in. Okay, let's try one more setting. Okay, so we have that one at 7 kilohertz now, and 7 kilohertz, and that's the second from the top. And I'll try adjusting this down. Okay. We'll see. 117 hertz. And so I guess there's one last setting. And we'll see what that does, okay? Okay, so the final setting here is the top jumper, the big capacitor. And that one is 200 and some hertz. And it goes down to very low frequencies when you twiddle with the frequency setting here. Okay. 75 hertz, probably even lower. I just didn't twist it all the way because this is not a great screwdriver. And so anyway, I don't know if I mentioned this. This is the output on this side where I'm hooking the, see it says ground, these 3 pins over here. It's ground on the bottom one. And the top pin is one type of output, I'm not sure, but let's try sticking it on the center output and see what happens. Okay, I guess maybe similar output, maybe they're biased differently. One of them might be biased through a transistor or something. Not exactly sure what the difference is. But anyway, here's our oscillator circuit. A cheap oscillator circuit, and looks like it's working. Finally got it working after about a day's worth of work on it. Okay, anyway, this is Dr. Janes, and thanks for watching.